In this experiment, we're going to take a look at the Arduino with a PlainDSP audio shield attached to it. We're going to use a device like a cell phone that can play audio and play sequences of beeps. The PlainDSP will then interpret those beeps as text. So how does this work? Well, we have a cell phone, or any machine that can play audio, that sends a sequence of tones. And those tones are picked up by a microphone on the PlainDSP, and then the Arduino is able to translate that sequence of tones into text and send it to the output of the computer. So how does that work? Well, it turns out that the PlainDSP is a special device with special code on the Arduino that can hear different frequencies and organize them very specially. It can do this by using what's called the fast Fourier transform, a very advanced mathematical concept that allows us to take things from one domain, for example the time domain with the PlainDSP hears, and transform it into the frequency domain. So something that's useful for us would be to know how many frequencies are present in the sound there on the left and decompose that and understand that by using the fast Fourier transform. So a sound that might sound like this, to the human, we can't really understand how many frequencies are present, maybe some of us. So the PlainDSP allows us to decompose that and understand what frequency information is there. So in this experiment, we used the tones that correspond to musical notes. The PlainDSP can hear these notes and then, as you know, can translate the time domain information into frequency domain information that we see on the right. So on the right we have several different notes overlaid at the same time, and we can see that the PlainDSP can recognize all of them. So some code was written so that we can translate sequences of notes into text. So as you can see here, the musical notes in this particular sequence corresponds to the letter H. So it takes 5 musical notes to create one letter. So how can we do this for any letter? What is the protocol that we follow? So in this case we have 5 different notes. The first 2 notes are required at the beginning of every letter, or beginning of every message, if you will. The second 2 notes, the combination of them, identify a letter. So there's a list that shows which combinations of notes correspond to which letters or symbols, and we can show that later. And finally, C#7 is required at the end of every letter just to identify the end of a message. So again, that sounds like this. So what can we do with this? Well, we can use machines to communicate to other machines over audio. So this is actually a pretty old concept, but it's kind of fun to do this with the PlainDSP and pretty much any audio device or any device that can play audio. So in our case, again, we used a cell phone so that it could spit out a sequence of tones, use the PlainDSP to take that in, and then trigger some sort of event. In our case, translate it to text. But really, you could do anything with it. You could turn on lights, you could flip triggers, you could open doors. It's kind of a neat little tool to use audio to trigger events using machines.